Today we will look at just the first half of the Chapter 6 review, Part 1 assignment. So we'll call this discussion Part 1A. Here we go. All right, number 16. At first glance, number 16 looks horrifyingly complicated and confusing. And you might be tempted to say, oh, I don't know. But let's slow down, don't panic, and let's look at it one piece at a time. The first thing I notice here, let's take note of this little detail here. I'll grab all this up and bring it up where we can see it better. All right. Do you remember this? If you don't remember this, you need to start remembering it quickly. This came up on page, where was it? I can refer you to the page number in the book where this was brought up. I wasn't planning on doing this, so now I've got to go search for it. It's on the left side in the bottom margin, and will I be able to find it? I'm wasting your time now. Okay, if I don't find it quickly, I'm good. There it is. On the bottom of page 382. On the bottom of 382, because they print a lot smaller than I do. They fit more information into that one little box. But the idea is this: if you arrange the functions in their logical order here, sine, cosine, tangent, and under those put the reciprocals. Reciprocal sine is cosecant, reciprocal cosine is secant, and reciprocal tangent is cotangent. And consider negative theta for each one. For these two and these two, sine of negative theta is equivalent to, can I grab just the negative sign? Not easily. Is equivalent to moving the negative sign out here. The same thing is true of its reciprocal. I'm not going to take time to do it, but I could grab that negative sign and just pull it out. For tangent and cotangent, same story. Exactly the same thing with tangent and cotangent. I can simply grab that negative sign and move it out here. So tangent of negative theta is the same thing as negative tangent of positive theta. You just pull out the negative signs for tangent and its reciprocal cotangent. The two in the middle, they're the exception. Oops. These two guys are the exception. The ones in the middle, even better than sine and tangent. The ones in the middle, all you have to do, and I really need to ungroup this to demonstrate for you. One moment, I can do this. I know I can. There we go. And group and ungroup. And with this one, all I do is take that negative sign and I simply toss it out the window. It doesn't show up over here. Just toss it out there. You just grab the negative sign and toss it for cosine and secant. All right, now that becomes very useful here, because the rule for the two on this side and the two on that side is you take the sign, move it out. Take the sign, move it out. Exactly what we have here. So we take that sign and we're going to move it out. So that's going to become positive pi over 4, and move it out, that minus becomes a plus. So now I'll get rid of this monster reminder and we'll fix this. I'll bet this is grouped. It's grouped. Let's ungroup it just to emphasize what I'm doing. All right, so I'm just going to grab that negative sign and I'm going to pull it over here. I'm going to get fancy and I'm going to move it right there, making that a positive. All right, so the first little complication is settled. Now, what do we do with this? We've got to figure out the cosecant of 3 pi over 4. Forget about that 4 for the moment. Let's just get the cosecant of 3 pi over 4. It would be, first of all, nice to understand what 3 pi over 4 looks like. Remember the unit circle? It's been a while since we've seen it. Oh, that's a terrible circle. Pretend that's a circle. Here, of course, we have 0. Here we have 1 pi. Go all the way around, we're back to 2 pi, and you know how that works. Well, what's halfway between 0 and 1 pi? That would be 1/2 pi, pi over 2. We're talking 3/4 pi. That's 1/4, 2/4, 3/4, 4/4. 3/4 pi is right here at the location we used to call 45 degrees. Well, we still do if we want to. These are radians, these are degrees. So, we now know where our triangle lies, we now know what the angle is. We're looking for cosecant. Well, cosecant is the reciprocal of, and yes, it is your responsibility to remember what cosecant is the reciprocal of. Cosecant is the reciprocal of sine. Well, what's sine? Oh, first of all, if this is a unit circle and the hypotenuse is therefore 1, it's also your responsibility to remember the legs. This leg will be square root of 2 over 2, sort of. Why do I say sort of? Because it's negative. And this one is positive square root of 2 over 2. Yes, you are responsible to remember these patterns for a 45-45 triangle. I can't memorize it for you. You must know it. All right, so cosecant being the reciprocal of sine, let's get sine first. Sine would be opposite over hypotenuse. You know your old friends. So, katoa, S-O-H. Sine is opposite over hypotenuse. So it's going to be square root of 2 over 2 over 1. That's sine. But we don't want sine. We want the reciprocal of sine. We want cosecant. So we flip this to 2 over square root of 2. And then we use our usual trick to get that radical out of the denominator. So we multiply by square root of 2 over square root of 2, which gives us 2 square root of 2 over 2. These cancel. So we have here square root of 2. May I now just get rid of the unit circle? Thank you. If you need to see it again, you have the power to rewind me. So we had square root of 2. All right. So this whole thing right here becomes square root of 2. But we have 4 square root of 2. And we haven't figured out the cotangent of pi over 4 yet. Another unit circle. Where's pi over 4? Here's 0. Here's 1 pi. Here's a half pi. Well, here's a 1/4 pi right there. 45 degrees. So we want cotangent. Let's do this first. 1 square root of 2 over 2 and square root of 2 over 2, both positive this time. Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. Oh, square root of 2 over 2 over square root of 2 over 2? Yeah, that's going to equal to 1. And the reciprocal of 1 is 1. So this whole thing just becomes 1. So we have 4 square root of 2 plus 1. And if you just don't panic, use your unit circle, use SOHCAHTOA, use your understanding of reciprocal functions, and it all comes together rather nicely. We're counting by 4s, so let's go on to number 20. This one is a little on the easier side, I think. First of all, take note, we have a negative theta here. How do we handle cosine of a negative? Cosine of a negative, the two guys in the middle here, sine, cosine, tangent, and their reciprocals. It's the ones in the middle where you drop the negative sign. So I can simply dive in here and erase that negative sign. That's the rule for cosine and secant. Just drop the negative sign. Okay, so what does that do for me then? Let's move on. Let's just get rid of that. We don't need that anymore. Okay. Now, let's figure out the sine of 270. Sine of 270, unit circle. Where is 270? This is 0, 90, 180, 270 down here. How do you draw a triangle right on the axis? Well, you don't. but we kind of fake it. We'll draw ourselves a little imaginary triangle here as if it were not exactly 270 degrees. We'll do this with the understanding that if this were really where it belongs, how big would this adjacent side be? It would actually be 0. And the opposite side would be -1. And the hypotenuse would be, as always, 1. So we just draw this little itty-bitty, skinny, imaginary triangle here. My theta is right there. And we pretend that there's a triangle when there really isn't. This really should be squished all the way down to a side of 0. All right, so sine, opposite over hypotenuse. So katawa, opposite, -1 over hypotenuse, +1. So the sine of 270 is -1. Plus cosine of 180. Just erase this. Doesn't take much to recreate one. There, there, there. 180 being over here. So that's going to be like this. Where in reality, if this were all the way down flat, the opposite side here would be 0. The hypotenuse is 1. The adjacent side is -1. Remember, the hypotenuse is always +1. So, cosine. So ka, toa, S-O-H-C-A-H, so ka. So we want adjacent over hypotenuse, that's -1. So we have -1 plus -1, we have a result of -2. And I'm just checking the answer I've written in my book here to make sure I didn't botch that along the way. And wouldn't you know it, for number 20, oh, I do have the answer here. Yep, -2, that's it. Now we move on to 24. Oh, 24 is a really easy one. Why do I say it's really easy? Well, first of all, notice that the degree measures are the same. And also notice that tangent and cotangent are, guess what? Yeah, they're reciprocals of each other. Sine, cosine, tangent, cotangent, secant, cosecant, what I call the natural order, reciprocals, reciprocals, reciprocals. Yes, tangent and cotangent are reciprocals. What happens anytime you multiply a number by its reciprocal? You always get 1. Done. We move on. That one was too easy. We move on to 28. 28. Okay, this one is another one similar to 24. We just have to remember what to do with this negative sign. Sine, cosine, tangent. These are the ones where we pull the negative sign out to the side. Here we pull the negative sign out to the side. Here we just drop the negative. So using that rule, the negative sign comes out. We have negative tangent of 20 times cotangent of 20. Well, we know what tangent times cotangent does. They are indeed reciprocals. They do indeed cancel out to a 1. So we have -1. 28, final answer, -1. Marvelously simple once you see the tricks. We now move on to number 32. A different kind of problem this time. They gave us the tangent of the mystery angle is 1/4. They also told us right here what quadrant it's in. You're going to see this every now and then. Don't let it baffle you. It just says that my theta is between 0 and pi/2. My theta is between 0 and pi/2. So I'm someplace in the first quadrant. Exactly where in the first quadrant? I don't care. I just know that I'm in the first quadrant. I'll just draw a triangle someplace in the first quadrant. Now I know the tangent is 1/4. Again, so ka, toa, tangent right there. Tangent is opposite over adjacent. So the opposite side of my mystery theta, the opposite side is 1, and the adjacent side is 4. Yes, I know we can see here that I clearly did not draw that angle at exactly the right place, but you know something? I don't care. So tangent being opposite over adjacent, 1 over 4, there it is. We need to know the hypotenuse. That goes back to 9th or 10th grade geometry. A squared plus b squared equals c squared. A squared plus b squared equals c squared, our old Pythagorean theorem, friend. So we have 1 squared plus 4 squared equals c squared. So we have 17 is c squared. So c must be the square root of 17. So we now know the hypotenuse. Now that we know the hypotenuse, wow, we know everything. From there we can find all the functions. Let's get rid of that. Okay. Why is cotangent super easy? Yes, because cotangent is just the reciprocal of tangent. See the yellow dotted lines? Yes. So if tangent is 1/4, cotangent must be 4 over 1. Now what about sine? Sine is opposite over hypotenuse. So, ka, toa. Opposite over hypotenuse. That's 1 over square root of 17, but you know you can't leave it that way. So we multiply by square root of 17 over square root of 17. We get a result of square root of 17 over 17 done with sine. Cosine is very much like sine, except it's adjacent over hypotenuse. It's 4 over square root of 17. I need some space. It's 4 over square root of 17. So we multiply again by square root of 17 over square root of 17, and we get 4 square root of 17 over 17. Done. 4 square root of 17 over 17 for cosine. For secant and cosecant, they're a little bit easier. Secant is the reciprocal of cosine. Well, if cosine is adjacent over hypotenuse, secant must be hypotenuse over adjacent. Hypotenuse over adjacent. Square root of 17 over 4. Square root of 17 over 4. And cosecant, being the reciprocal of sine, yes, I could go back here to this and flip that and then get rid of the radical, but why go to that much trouble when I know that cosecant is just not opposite over hypotenuse, but hypotenuse over opposite. Hypotenuse over opposite. Square root of 17 over 1. The easier way to do it, over 1. Easier than say, oh, let's see, what do? We flip that, and then we multiply by square root of 17 over square root of 17. That gives us 17, square root of 17 over 17. Those cancel. We get square root of 17. Yeah, we did. But just doing hypotenuse over opposite was a lot quicker and simpler. All right, we move on to number 36. All right, this time we're told the cosecant is -5/3. And we're told that cotangent is negative. Oh. Well, if cotangent is negative, cotangent's reciprocal must also be negative, so tangent is negative. Now we can make use of our old friend, all students take chemistry. All students take chemistry. This says that all 3 functions are positive in the first quadrant, only sine is positive in the second, only tangent is positive in the third, and only cosine is positive in the fourth. Well, here cotangent is negative, therefore its reciprocal, tangent, must also be negative. So tangent can't be here, can't be here, it could be here or here. These are the only places where tangent will be negative, because here, all, and here, it's positive. So, we know that our angle is in one of these 2 quadrants. Let's just get rid of those. Now we look at this guy, cosecant. Oh, but cosecant is the reciprocal of sine. Cosecant is the reciprocal of sine. So where is sine negative? sine and cosecant are negative where all students, okay, here it's positive, take chemistry. It could be negative here or it could be negative here. The only quadrant that fits both requirements at the same time is quadrant 4. We are in quadrant 4. So we'll draw ourselves a triangle in quadrant 4. We know the cosecant is negative 5/3. We don't really care about the sine being negative because we already dealt with that. That told us which quadrant we were in. So cosecant is 5/3. Well, cosecant is the reciprocal of sine, so sine must be 3/5. Sine being opposite over hypotenuse, opposite 3, hypotenuse 5. If we put the 3 here and the 5 there, then that gives us a cosecant of 5/3, because that would be hypotenuse over adjacent. Hypotenuse over opposite. Hypotenuse over opposite. We can see here that yes, indeed, that opposite is negative 3. That's why the cosecant is negative 5/3. All right, with that knowledge, we are now ready to find everything. Oh, not quite yet. One little missing detail. We don't know this side yet, but yes, we do. If you remember your very basic geometry and a little bit of Pythagorean theorem, you'll remember that if you have a hypotenuse of 5 and a leg of 3 in a right triangle, the other leg has to be 4. Remember the famous 3-4-5 ratio? How would you figure that out otherwise? You would start with a squared plus b squared equals c squared. You would say the unknown x squared, whatever you want to call it, plus 3 squared equals 25. Subtract 9 from both sides, take the square root, you get 4. That's trivial beginning algebra stuff. Now we can do them all. Sine. Well, sine is just reciprocal of this guy. We don't even have to look at the unit circle for sine, because we know it's the reciprocal of cosecant, so it's negative 3/5. Cosine, adjacent over hypotenuse. Adjacent over hypotenuse, that's 4/5. Tangent, opposite over adjacent. Opposite over adjacent, that's negative 3/4. And then the reciprocals. Cotangent, the reciprocal of tangent, so that's negative 4/3. Secant, the reciprocal of cosine, so that's going to be 5/4. And we already knew what the cosecant was because it was given to us. And we're done. Not too bad. Please do not think of, there's a word, I just lost the word. Tedious, yes. Do not think of tedious as being equal with hard. Tedious and hard do not have to go together. If you think tedious is hard, there's another word we use for that. It's the word lazy. No, tedious and hard don't go together. Tedious, yes. Hard, no. All right. Oh, okay. Decided I wanted to stop there. There is more to look at. As you can see here, we have much more to look at. But we're going to stop there, and we'll finish up with part B of Part 1B, the second half of Part 1, next time. And there is no new assignment now, but there will be a new assignment which has already been posted on Google Classroom that will be due not Wednesday but Friday. So you can work on that ahead, which would be a very good idea. But you can put it off until Friday morning for all I care. It's Part 2 is a fairly short assignment. But nothing new for now. I'll send you the video for Part 1B on Wednesday. And that's it. We'll have, by the way, I plan on having a Zoom meeting next week for those who are interested. For those who would like a more face-to-face interaction kind of review, we'll do that next week. And getting ready for the test, which is now being delayed by 1 week because of circumstances somewhat beyond my control. So the test will be, what was it going to be, May 1st, I believe. Originally scheduled for this coming Friday. We're putting it off 1 entire week because I can only give tests on Fridays. A little frustrating, but it's for the best. Alright, that's it, see you later.